Hello and welcome to this World Cement Spotlight. My name is David Bisley and I'm the editor of World Cement. Today I'm joined by Michael Tay, Advanced Analytics Product Manager at Rockwell Automation. Since 1985, Michael has been working with model-driven and real-time solutions to drive manufacturing and process improvements across a range of industries, including cement, minerals, biofuels and refining. In this session we'll be reviewing some of the topics raised in Michael's recent article. Entitled Smooth Sailing, this article explains how machine learning can help save energy, reduce downtime and predict equipment failures, thus enabling the smooth running of cement plant operations. Michael, thank you for joining us today. It's great to have you here. This is a really interesting topic and I'm looking forward to hearing your thoughts on some of the questions we have lined up for you. So, let's begin with something of a broader question. Machine learning has become something of a buzzword in the industry, along with other phrases like artificial intelligence and the industrial Internet of Things. For those who may not know, can you explain exactly what is meant by machine learning?
Yeah, sure, David. Machine learning uses intelligent algorithms to quickly learn from data to identify useful patterns. Okay. Those can be anomalies, they can be developing failures, or approach to targeted performance. And one of the key points is it's not magic. Most of the time, it just more quickly learns and then repeatedly executes something a good engineer could discover with time on the same data. So it rarely discovers a needle in the haystack, but it can take that engineer's knowledge and detect, hundreds of bricks in thousands of haystacks over time. Right? And that expands their capacity to deliver value.
Now, as I understand it, there are two main methods used in machine learning. Supervised learning and unsupervised learning. Could you explain a bit about the difference between these?
Yes, the main difference is supervised learning is learning to recognize identified patterns based on a human-labeled result. For example, here's a machine failure from an underperforming oil system. And unsupervised learning is learning without labeled result. And everybody who runs a lab for a quality system knows measurement and labeling can be expensive. So unsupervised learning learns what that same machine looks like when things are going well, and then gives you an alarm when it's off. And many customers who want predictive maintenance on that same machine, but they don't have labeled failures, they need unsupervised learning. It's better to have labels, but if you don't have them, unsupervised learning is a good alternative.
So, with reference to the cement industry specifically, can you talk a bit about the different machine learning applications that you've seen applied in the cement sector?
Yeah, there's a lot of opportunities. Anomaly detection, again, it's looking for deviations from good behavior. So you could look at kiln wall buildup or low volume in a ball mill, so you've lost too many balls. So you're looking for those deviations from normal. Predictive KPI, they can answer questions like, is your blane or your cement free lime on track? Or are you getting excessive fines? It's a real value. And then predictive maintenance just tracks like drive or conveyor problems or shaker issues on your kiln cooler. Predictive maintenance usually looks at things that move and fail. And then MPC is a closed loop prescriptive. The other are predictive analytic. It's a prescriptive analytic. It drives kilns to maximum capacity or mills to avoid overgrinding and manage fines losses. You can do oil balancing or oil fuel system optimization on the kiln. It's ultimately driving results to get those same values.
So who would build these types of machine learning applications in the cement sector?
Yeah, there's a variety of different tools designed for different users. The classic method is data scientists, but there are other tools designed for plant engineers that automate more of the data science, and then domain specialists. So there's tool sets for a variety of different kind of stakeholders or people with expertise. The newest area of innovation in machine learning is focused on enabling people with domain knowledge, but not data science, to leverage that knowledge and get better solutions.
Where should a cement company get started when it comes to machine learning?
We always recommend to look for significant and costly variations in performance. If your plant can do better some of the time, it's it's generally a good opportunity to kind of drive that to be better all the time or more of the time. Alternatively, you can look where there's performance gaps between you and industry peers. So if your company has 10 sites and you've got very poor energy efficiency on a kiln, it might be the place to look. Again, it's possible to investigate if ML can identify and overcome gaps, but you're looking for gaps.
Do you think there's any truth to the argument that the semi-chaotic nature of cement production is too challenging or complicated for the fully effective use of machine learning?
We haven't found it so. There's always opportunities for improvement, and that same maturity and industrial understanding that the cement industry has lets them drive to solutions that work. You know, what's more difficult is delivering knowledge from just data with very little understanding or background. And everything has some level of noise, although cement's on that extreme end. But machine learning is designed to assist where noise makes discovery challenging.
Okay. Which aspects of cement manufacture typically benefit the most from machine learning? And are there any aspects of that process that don't benefit at all?
We've found opportunities across the entire cement operations. People have applied predictive maintenance on machines in the quarry and transport to soft sensors and MPC on the finish mill and everything in between. Everywhere we've been asked to apply technology improvements, improvements have been achieved. That said, we follow an engineering process, so we don't just assume there are value, but we estimate the value up front, or we evaluate